Well, I'm here to speak about my experience from last summer. I was over at the NASA Langley Research Center for 2 weeks at the end of July, and any teacher who reads that title up there probably just got a few reactions. One, probably shiver down their spine. Their eyes probably started drooping, and their hands instantly started looking for a pillow. Because any teacher knows that professional development just is, for 99 times out of 100, is just considered a waste of time, boring, it's not useful, or you get 1% of your time is actually useful, the rest of the time you could be spent, well, napping. Sometimes that actually happens. So when I saw about this time last year, I saw the opportunity to work with NASA on something, I jumped at the chance. Excellent. Before we go into any further detail, I want to go into a little detail about myself. My name is Joe Herrington. I graduated from Northeastern University in Boston in 2003 with a BA in physics. I've been teaching in Boston since the year after that, once I finally got a job. And that I'm now in my 7th year, where I've been teaching physics as well as an introduction to engineering class at the John D. O'Brien School of Math and Science, one of the 3 exam schools in the city of Boston. Next slide, please. So you may ask yourself, well, why ModSim? Why aeronautics? Why engineering, period? Well, for any teacher in the room, you've seen those faces. You've seen those just looks of, really, just more stuff? When's June coming around? And it's just that there's no engagement. There's a lack of excitement. There's just malaise. And the goal of ModSim, the goal of, well, teachers in general, is to turn that into something like that. I have weird students. But it works. When you do something in class that the students can see that it means something, that it applies to the real world, that's fun, that they get to use their hands, as well as do the calculations that we want them to do, they get excited. Next slide, please. So my experience. First thing, we got to see some really cool stuff. This was a wrench that was designed and then built by a machine called the electron beam freeform fabrication. The idea of this was that, well, when you go to the moon, when you go to space and you lose a wrench, you left it at home, it's in your dresser drawer, it's in your other pair of pants. You can't exactly say, I'll be right back and go get it. You need to be able to either work around it or come up with some other idea, some other way to fix whatever need that was broken. Well, this machine does just that. Takes wire and an electron beam, melts the wire, and builds you a wrench. The idea is that you can do this when you're off in space, when you're on another planet, and it was one of the coolest things that we got to see. Next, please. And then you get some cool stuff too. We were lucky enough, my partner Jessica and I were lucky enough to work with a scientist that I'll talk more about in a moment. We actually got a piece of a shuttle's heat shield tile. And to me that was just fantastic. I couldn't ask for anything better than that. Next. We also got to see some testing apparatus for the Orion spacecraft. That's what that giant monstrosity is on the left side. Next, please. And one more. We also got to see the gantry down in Langley, which was, the picture just doesn't do it justice. It's 150 feet tall. It's ginormous. But that is such a piece of historic and exciting material for anybody that's science related, because all the Apollo astronauts tested landing on that piece of machinery. So when you think about that, the history that's involved, that's exciting. Next, please. And you get to wear a flight suit. It's just really cool. Next. All right, so while I was there, I got to work with a wonderful scientist Dr. Stephen Scott, who's the chief engineer in the Structures and Materials Lab at the Langley Research Center. Great guy, really knowledgeable, really personable, and a terrific field trip organizer, because every single day we met with him, we talked about our project, got a lot of good information from him, and then he would take us off and show us something that nobody else got to see. He currently focuses on probabilistic structural design, working on the Orion spacecraft and things like that, working on new materials for it, testing out how they work, how they stand up to different stresses, and things like that. So from the different things we got to see and talk to him about, my partner and I designed a lesson. First, we saw it looks like a pill. It looks like something you would pop in your mouth, except for it's much larger and made of metal. But it's an expandable lunar habitat. It starts off smaller and expands so that you have larger space to live in space. And in the middle of it, in this region here, these are all nylon straps. And so they need to be able to expand this and fill it with air so that people in it can breathe. And so, if you click next, they would test those straps under tension. They would attach it over two pulleys and pull it until it snapped. Test it for how much stress it could hold until it snapped, so they could have an accurate representation of how much stress and how much pressure they could put inside of one of these habitats and make sure that it was safe for the astronauts inside. We also got to see some of the struts from the lunar lander, like the new Orion spacecraft lander. And these things, although they'll be traveling hopefully slowly when they reach other surfaces, they would be under a good amount of pressure. And all this stress would be in the form of compression, however. And they would test things like this in that machine, which is called the million-pound machine. Creates 1 million pounds of force and just crushes anything that gets put underneath it. So we took this idea that, well, you could have the best design in the world, but if the materials you're using aren't up to the challenge, it would fail miserably. And in our lesson, we took this idea of what's called a 4-point bending test. You have 2 points on the end, supporting some piece of material, and 2 other points that would push down on it, applying some stress to the point of failure. So in our lesson, we would discuss the difference between stress and strength, and then get into, well, maybe if you put a different piece of material in there, or even the same type of material, but a different piece of it, you get these different quantities. You can get a wide range within any given piece of metal, piece of wood in this case, and it really matters the quality control of when you manufacture it. And students don't have this idea. So when they go to build something, they say, oh, just use a piece of wood, whatever, slap it in there. Well, the different sizes, the different types of wood that you use to build something can have a very large impact on what happens when you start testing with it. Then we would take all that data over the entire class, plot it, and so you get a sense of statistical analysis as well as the design process, and introduce this idea of this factor of safety, where you've got that wide range, and so you want to build your design so that it can hold, so 99% of the time, hopefully more, but 99% of the time, it would be able to hold what you plan on holding, be able to take those pieces of data and apply it to building something thereafter. After you've got this data, say, okay, we know 99% of the time that these pieces of popsicle sticks, whatever they are, will hold this amount of stress. This amount of strength is in that material. Then what are you doing? Well, a lot of times in, say, math class or something, it kind of stops there, but it needs some relevance. You need to be able to take this data and apply it to something. So in our lesson, we use the West Point Bridge design. It's a very good program, and they've actually got a new version out that's 3-dimensional, and you can kind of walk across the bridge almost and see how it's flexing. And the most important part, as far as I'm concerned, is the design through iteration. Taking something, testing it, whether to do it kind of as an engineer would, using computer simulations, testing it, it fails. It falls under its own weight. You design it and say, this thing's fantastic. You hit play and into the drink it goes. So you say, all right, well, what happened? You redesign, test it again, falls in the drink again. You keep testing and keep testing while looking at the data to try to figure out what's going on with it. Then they take those ideas and through their iteration, once they have a working design, apply it to popsicle stick bridges, balsa wood bridges, whatever materials you have available, take that data, apply the mathematical concepts, and do a 3-point test. Instead of a 4, you can do a 4 as well, on their bridges and test and see how well that data applied to how they constructed their bridge. And really see that this is what engineers do. It's not, oh, they're super smart. It came up right out of the blue and done and off building the bridge. There was a lot of work that was done for maybe years ahead of time that went into building those bridges. So give them a real sense of how that process goes. And there was just so many opportunities. So that was our lesson, but in addition to working with Dr. Scotti, just all the opportunities, all the different education materials that we had available. This was one activity that I did back in the fall that was directly from NASA. This is a rocket launch that Danae and Brandon helped us out with last summer. The kids loved it. I had them calculate the velocity lifting off the rocket and asked them, tell me where to stand launching at 45 degrees, and had them try to hit me. And a few of the groups nailed me right in the face. And it worked out fantastic. They thought it was great. My students probably just as of a few hours ago completed hopefully the flyby math activity that was again from NASA. There was just so many materials and so many ideas that were available to us that it was two of the best weeks that I've ever spent anywhere and doing anything, and definitely two of the best weeks of professional development that I've ever been a part of and could ever hope to be. And as my partner said, and as it was written on a wall down at Langley, NASA is truly bringing geeky back. Thank you very much.